We have now mutable variables as one way of implementing state. So here I've got a mutable variable weight. I have feed and get size that communicate through those variables in the sense that get size returns the current weight and feed changes the value of weight by using the current value but adding 1 to it and assigning that into weight. Mutable variables are only one form of state, however. Another common form of state is to have an object and be able to change that object. So here I have a non-mutable variable weight that is equal to a box, and I have a 0 initially inside the box. So a box created by this Shplait function box is a mutable object, and weight, as defined here, is always going to refer to that particular box. But the inside of a box can change. That is, the value that's inside this box will change. Get size now, instead of just returning weight, uses unbox to get the value out of that box, while feed uses unbox to get the current value, adds 1 to it, and then installs that increased number as the current value of weight using setBox. That is, we have new functions box, unbox, and setBox in Shplait. Box takes any kind of thing and gives me a box of that kind of thing. Unbox takes a box of some kind of thing and gives me that kind of thing out of the box. And setBox takes a box of that some kind of thing and a new value of that kind of thing, changes the box to have that new value, and then doesn't have to return anything because its job is just to change the box. So we use void to represent an invisible, useless kind of result. The intent is that setBox has an effect that you observe by using unbox. Just to put that in Java terms, you can imagine defining a Java class box of t, and then you would allocate a new box object using new box. We are doing the same thing in Shplait and soon to be in Mo with this box operation, box function, that takes a 0 corresponding to the initial value, which is like the initial field value inside the box. We will use begin to just sequence 2 terms. In Shplait, we would use block, but we're going to use a simpler version, begin, that just has expressions in Mo. In Java, to change a box, you would use b.v equals 10. Again, in Shplait and in Mo, it's b. We're going to use setBox to do the same job, and unbox gets the current value out of the box, just like b.v would in Java. So this is where we're going, adding box, setBox, unbox, and begin to Mo. That means our new grammar will look like this. We have all the old cases, plus these new forms in our language. So for example, in extended Mo, if we say let b equals box 0, set that box b to 10, and unbox it, we should get a 10 out of the box. Reflecting these changes to the grammar, then we have these new changes in our X data type, the abstract representation of the grammar. Changing the parser to deal with these new forms is straightforward, so we'll look more at how the interpreter can work.